question number 1, work out 2 3/5 minus 1 5/6. So to do this, we're going to make both fractions top heavy. And to do that, we're going to multiply the 2 and the 5 together and then add on the 3. So 2 times 5 is 10, add the 3 is 13, and that stays out of 5, stays out of the same denominator. Minus, and then same with this fraction, 1 times 6 is 6, add the 5 is 11, and that stays out of 6. Now when we add and subtract fractions, we want to make the denominators the same. The denominators are the bottom numbers. So the first number in the 5 times table and the 6 times table is 30. So I'm going to make both of these out of 30. To do that, I've multiplied this fraction on the bottom by 6. So I also need to multiply the numerator, the top number, by 6 in order to keep those fractions equivalent. So 13 times 6, well 10 times 6 is 60, and 3 times 6 is 18, so add that together and you get 78. For the second fraction, I've multiplied the denominator by 5, so I also need to multiply the numerator by 5, and that's going to be 55 over 30. Now that the denominators are the same, we can just subtract that. So 78 take away 55 is 23 over 30. I can't simplify that because there's no common factors between 23 and 30. So that's my final answer, and that's a 3-mark question. ABCDE is a pentagon. Work out the area of ABCDE. So we've given some information here on the diagram. What I'm going to do first is split this into a rectangle and a triangle. Now we can work out the area of this rectangle because we know that the area of a rectangle is the base multiplied by the height. So we're going to do 8 multiplied by 4, and 8 times 4 is 32. So that's great. We've got the area of that, 32 centimetres squared. That's the area of this part here. Now we've just got to do the area of the triangle. Now to do the area of a triangle, we need to do the base multiplied by the height, but we don't have the height here. This is the height that we need. We've actually at the minute only got 5, which is the sloped height, and we know that this here is 8 because it's 4 here and 4 here to match at the bottom. So I'm going to look at this right angled triangle, and I'm going to draw it again down here, and this has a width of 4 and the longest side, the sloping side, is 5. Now I need to know how tall it is so that I can work out the area of the triangle and do base times height divided by 2. To work that out, we're going to need to use Pythagoras. So Pythagoras is how we work out the missing side in a right angled triangle. And because we've already got the longest side, the hypotenuse, I'm going to do 5 squared take away 4 squared. Now that's 25 take away 16, which is 9. And to find out the length of this side here, we're going to square root that number. So the square root of 9 is 3. And that makes sense. It's a non-calculator paper, so we wouldn't be asked to get a decimal answer when we square root or anything like that. We'd get a square number. So that's 3, and now I can do the area of those triangles. So base times height is 4 times 3 divided by 2. So 12 divided by 2 is 6. So this triangle has an area of 6, and this triangle has an area of 6. So I've got 32 for the rectangle, add 6 is going to be 44 centimetres squared. The diagram shows a rectangular wall. Frank is going to cover the wall with rectangular tiles. Each tile is 60 centimetres by 30 centimetres. 3/5 of the tiles will be white, some of the tiles will be green and the rest will be blue. The ratio of the number of green tiles to the number of blue tiles will be 1 to 3. Assuming there are no gaps between the tiles, how many tiles of each colour will Frank need? So looking at this wall, we can see that it's got a height of 1.8 and we can see that it's got a width of 6 metres, and we want to convert that ideally into centimetres. So 1.8 metres is 180 centimetres, and 6 metres is 600 centimetres because every metre is 100 centimetres. And then we're looking, a tile is 60 by 30. Now it doesn't say in which orientation, so I'm just going to assume that it's this way round, 30 tall and 60 wide. So 30 tall, I need to know how many 30s are going to fit going up this wall. So how many 30s are going to fit into 180? And if I do 180 divided by 30, it fits in 6 times. So I'm going to get 6 rows going across this wall. So 1, 2, 3, 4, 5, 6 at the top. So I've got 6 rows. That's how many tiles would fit going up. Now going across, I've got a width of 60 and the wall is 600 across. So how many 60s fit into 600? 600 divided by 60 is 10. So I'm going to fit 10 columns. I'm not going to draw them all, but you get the idea. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 going across. 10 times 6, because I've got 10 columns and 6 rows, means there are 60 tiles on the wall. Now we know that 3/5 of the tiles will be white, so you want to do 3/5 of 60. Now to do a fraction of an amount, we divide by the bottom and then times by the top. 60 divided by 5 is 12, and 12 times 3 is 36. So 36 tiles will be white. And then it says the ratio of the number of green tiles to the number of blue tiles is 1 to 3. So what's left? Because we're not including any of the white tiles in this ratio. We've got 60 tiles altogether, minus the 36 white tiles leaves us with 24 tiles. And I'm going to share that 24 in the ratio 1 to 3. Now that means dividing it into 4 piles. 24 divided by 4 is 6. So that means I've got 6 on this pile and 6, 6, 6 on these piles. So the ratio 1 to 3 becomes 6 to 18. So I've got 6 green tiles because that's first in my ratio, and I've got 18 blue tiles. So converting that to my answer, I've got 36 white tiles, I've got 6 green tiles, and I've got 18 blue tiles. And if we added that up, we could check that adds to 60. So we're happy that we've got the right answer, and 5 marks for that question, so that was great. Now Frank is told that he should leave gaps between the tiles. If Frank leaves gaps between the tiles, how could this affect the number of tiles he needs? So we're going to say that if he leaves gaps, then he will need less tiles. Great. Work out an estimate for the value of 43.2 times the square root of 99.05 all over 0.193. So this is a non-calculator question, and we're asked to work out an estimate. So we're allowed to round all of the numbers to one significant figure. So 43.2, I'm just going to say that that's 40. And we're multiplying that by the square root of 100. In the case of a square root, I'd just go to the closest square number so that we can do it easily. And we're going to divide that by 0.2. Now, that is the bit that normally causes a few problems. If we're rounding to one significant figure, 1 is your first significant figure. Zeros don't count until you've already started counting. And then you want to chop the number after that. Check the next number, which is a 9, which rounds up. So hopefully that makes sense why I've rounded it to 0.2. And that is 40 times 10, because 10 is the square root of 100, all divided by 0.2, which is 400 divided by 0.2. Now, dividing by 0.2 is quite tricky, but it's easier if we times everything by 5, because if we multiply by 5, the denominator is going to just become 1. And if we multiply by 5 on the numerator, we're not changed the question, we're just using an equivalent fraction. So that would be 2,000 over 1. If that doesn't make sense, you could maybe think about multiplying it by 10 on the bottom and 10 on the top. So that would be 4,000 divided by 2. And 4,000 divided by 2 is 2,000. So whichever way you look at it, you're going to get an answer of 2,000. And that's just using equivalent fractions. So because I've times the bottom and the top, I've kept the question the same. So that one's just 2,000. A company orders a number of bottles from a factory. The 8 machines in the factory could make all of the bottles in 5 days. All of the machines work at the same rate. For 2 days, only 4 machines are used to make the bottles. From the 3rd day, all 8 machines are used to make the bottles. Work out the total number of days taken to make all of the bottles. So, the first thing we want to do is work out how long would it just take one machine, and work out how many days that would take. So if it takes 8 machines, 5 days, if only one machine was working, you've got 8 times less machines doing the work. So if you've got 8 times less machines, it's going to take 8 times as long. So it's going to take 8 times longer. So we're going to do 5 times 8, and that means it would take 40 days for one machine to do all of the work. So it says for 2 days, only 4 machines are working. Now, in those 2 days, if 4 machines are working for 2 days, that is the same as 8 days work. So 2 days with 4 machines working is the same as 8 days worth of work. Now we know that we need 40 days worth of work altogether in order to get all of the work done. If 8 days have already happened, then we've got 32 more days of work needed. I've just done 40, take away 8. Then it says from the third day, all 8 machines are being used again. Great. So from the third day, we've got 8 machines being used. 32 divided by 8 means it's going to take 4 more days. What we need to remember though is that we had those 2 initial days with 4 of the machines working. So I had 2 days working to begin with. It's going to take 4 more days to do the other 32 days of work using all of the machines. So in total, 6 days. Jo measured the heights of students in 4 different classes. She drew a cumulative frequency graph and a box plot for each class. So we've got 4 different cumulative frequency graphs here, and we're asked to match them up to the box plots below. So to do that, we need to know the key pieces of information that we see on a box plot. So with the box plots, we've got this box, and this middle value within the box is the median. The top of the box is called the upper quartile, and the bottom of the box is called the lower quartile. Now we can get all of those values off of a cumulative frequency graph. To read those measures off of a cumulative frequency graph, we first need to think how many pieces of data has it got, and in all of these cases there are 30 pieces of data. So we will find the median by reading across at 15, hitting the graph and then going down. So I can see that for this class A, the median is at 160. Now to get the upper quartile, we go halfway between the median and the top of the data. So in this case, that's going to be here, and it would be 22.5. But we just read across here, hit the graph, go down with a ruler, and we can see that that's going to be, 166 or so. And then here for the lower quartile, that's halfway between the median and the bottom of the data. So that's going to be 152, let's just say 153. There we go. So what we're looking for is a box plot that matches that. And hopefully looking at these, you can see that that makes sense to be Y. We've got that median at 160, and we've got the lower quartile here and the upper quartile here, and it's all between the middle of the graph. So that's that one. So I'm going to say that A is Y. Looking at B, I'm going to do the exact same thing. I'm going to read across in the middle of the data to get the median, hit the graph and go down. That's your median. Your upper quartile is here, and your lower quartile is here. So for this one, our box plot is skewed over to this side. So we can see all of the data is really low, and that one is going to be X. For C, again, we're going to read across. The median is really high on this one. And then the lower quartile and the upper quartile. So a really high box plot within the data means everyone in that class was quite tall. So that's going to be Z. And then for D, process of elimination, but let's just check. We've got the median, the upper quartile really high, the lower quartile really low, and that means that data is really spread out. We've got a large interquartile range, which is the difference between the upper quartile and the lower quartile. The bigger that is, the more spread out the data is, and we can see that that fits with W. So I've got A is Y, B is X, C is Z, and D is W. We just fill that in here. So A was Y, B was X, then Z, and then Y. And then W. There we go. So that's that one. Prove algebraically that the difference between any 2 different odd numbers is an even number. Okay, so difference means takeaway, and any 2 different odd numbers is an even number. Now, this is a proof. So we can't just say, oh, well, 5 is an odd number and 3 is an odd number, and if I take it away, I get 2. Yes, okay, that works for that example, but if we're proving it, we have to use algebra, and we have to show that it works for any value. So we're going to have to use some letters here. We're going to have to use some algebra. Now, to do a proof, even numbers are written 2n because we're essentially saying if it's even, it's in the 2 times table, and 2n is the nth term for the 2 times table. So if you want an odd number, you need to use 2n, add 1. You're saying a number in the 2 times table, but just add an extra 1 bigger. Now this says 2 different odd numbers, so they're not related to each other in any way. So I'm going to do 2n add 1, and then I'm going to use 2m add 1 to mean a completely different number. Now difference means take away, so I'm going to do 2m add 1, take away 2n add 1. So these are 2 different odd numbers, and I'm doing the difference between them by taking them away. Now if I'm going to take that away, I've got 2m minus 2n, but then I've got 1 take away 1, and that would just go. So this is what I'm left with. How can I show that that's an even number? Well, the easiest way to show that that's even is to factorise it. I can see that this part is in the 2 times table and this part is in the 2 times table. So altogether it's 2 lots of m minus n. And I'm going to say therefore, we use those 3 dots in maths to show therefore. Therefore, even as 2 is a factor. Perfect. And that's it done. Okay, so this question would typically be done by completing the square, but I don't love that method for this question, so I'm going to do it a slightly different way. Here is a sketch of a vertical cross-section through the centre of a bowl. The cross-section is the shaded region between the curve and the x-axis, so the grey bit. The curve has equation y equals x squared over 10 minus 3x, where x and y are both measured in centimetres. Find the depth of the bowl. So this is a quadratic. It's a quadratic because it's got that U shape, and we can see the x squared in the formula, and that tells us it's a quadratic or a parabola, and we get that U shape. Now, there are a few key points to work out on a quadratic, and that is the roots or the solutions, which are the 2 places where it crosses the x-axis, and also the turning point. Now, if you want the depth of the bowl, then you're asking really for that turning point. You want to know where it turns and how low that goes below the x-axis. If I can find these 2 points though, I'll know that this turning point is halfway. And then I can use that to get the y coordinate. And I'm actually going to use this method here because I think it's easier. So my formula is this: y equals x squared over 10 minus 3x. To get the roots of the quadratic, this point and this point, we're going to factorise that. So that factorises to be x, open brackets, x over 10 minus 3. Now, to find the 2 solutions, we want to make that equal 0 because we're trying to find out when it crosses the x-axis. So I'm going to say that that needs to equal 0. And when would that equal 0? Well, it would either equal 0 when x was equal to 0, because if that x was 0, then the whole thing would be 0, because 0 times anything is 0, or it's when the bracket equals 0. So I know that this one's 0. That was nice and straightforward. But the bracket equaling 0 would be x over 10 minus 3 equals 0. I'm going to add 3 to both sides. So x over 10 equals 3. And so x multiplying both sides by 10, x equals 30. So I now know that this coordinate is 30, which means the turning point is when x equals 15, because we know that turning point is going to be in the middle because it's symmetrical. So I now know that when x is 15, we'll get the lowest point for y. So I'm going to use this formula to do that. So y equals x squared over 10 minus 3x, and I know that the lowest y, the depth of the bowl, is when x is 15. So y equals 15 squared over 10 minus 3 lots of 15. And that is 225 divided by 10, take away 45, which is 22.5, take away 45, which is minus 22.5. So that tells me that this coordinate here is 15 minus 22.5. And so the depth of the bowl, find the depth of the bowl, is just 22.5. I know that technically it's minus 22.5, but if we're just talking about depth, we don't need the minus. It has a depth of 22.5. A, B and D are points on the circumference of a circle, centre O. So we're told that O is the middle of the circle. That's quite key. EDC is a tangent to the circle. So that's going to be meeting the radius at 90 degrees. That's important information. And angle BDC, so going from B to D to C, is 57 degrees. Fabulous. Find the size of angle AOB. So they want this one here. Now, here's the key. You must give a reason for each stage of your working, so we're going to need to do some writing here. So, first thing I'm going to do is use the fact that I know that a radius and a tangent meet at 90 degrees. I'm going to write radius and tangent meet at 90 degrees. And that means I know that this is a right angle here. So this part must be 33 degrees. So 90 minus 57 is 33 degrees. So that bit there is 33. Now, because this is the centre of the circle, and we've got a radius here and a radius here, I know that the triangle BOD is an isosceles triangle, because this side is the same length as this side. So then I also know that this angle is 33 degrees. So base angles in an isosceles triangle are equal. And we've also used the fact that the radius are the same. So radii, plural of radius, radii are equal. And so then angles in a triangle add up to 180. I've got 33, add 33, which is 66. And 180 degrees minus 66. More on the floor, borrow from next door. 10 take 6 is 4, 7 take 6 is 1, and 1 take nothing is 1. So I've got 114 degrees here. Now if I do 180 take away 114, looking at this straight line, this bit is 66 degrees. So I've used angles in a triangle add up to 180 degrees, and angles on a straight line, also add up to 180 degrees. I promise my handwriting is better in real life. It's harder on the to do it on the screen. Fabulous. So that's it. So we've done it all, and we've said that x equals 66 AOB, and you can write angle AOB like that equals 66 degrees. ABD is a right-angled triangle. C is the point on BD such that angle ACB is 90 degrees, a right angle. Prove that triangle ABD, that's the whole thing, is similar to triangle CBA, and that's just that triangle there. So, in order to do that, we need to show that the two triangles have all of their angles the same. So if you can show that the smaller triangle and the bigger triangle have matching angles, so this angle is the same as this angle is the same as this angle, and this angle is the same as this angle. If you can show that, then you're essentially showing that one is a bigger version of the other. Now we're giving no angles here, and we've got no way of working it out. So in that case, and again, because it's a proof, it feels a little bit like we should be using algebra. So I'm going to go ahead and call this angle x. Now if I call that angle x, I know that looking at the whole triangle, looking at triangle ABD, this is a right angle. And so this angle up here would need to be 180, take away 90, take away x, because I'm taking away this angle and I'm taking away this angle in order to get this one. And we know that that would add up to 180. That simplifies to just be 90 minus x, because I've got 180 take away 90, which just leaves us with 90, and we've still got the minus x. So if the angle at D is x, then the angle at B is 90 minus x. And by the same logic, if this angle is 90 minus x, and then I take that away from 180, and I take away this 90, because I'm looking at this triangle now, 180 take away 90 minus x, take away 90, is 90 minus 90 minus x, which is 90 take away 90 is nothing, and minus x is just x. We knew that was going to happen because we saw in the other triangle that that's what it needed to be. So now I've got one triangle with x minus 90 minus x and 90, and the bigger triangle with x, 90 minus x and 90. And so therefore they are similar because all of their angles are the same. Show that 3 add root 2 over 5 add root 8 can be written as 11 minus root 2 over 17. So this is a question with a surd on the bottom of a fraction, and we can never leave surds on the bottom of a fraction. So in order to get rid of that surd, we need to rationalise. So rationalise just means getting rid of the surd on the bottom of a fraction. Now if I was given something like 11 over root 5, to get rid of the surd from the bottom of the fraction, I would just be multiplying by root 5 and root 5 on the bottom and root 5 on the top. Because when you times a surd by itself, root 5 times root 5 is root 25, so that's just 5 on the denominator and then 11 root 5 on the top. Now that might look more complicated, but you've got rid of the surd from the bottom of the fraction and that's it. Now the problem with the question that we've been given here is that we can't do that. If we multiplied by root 8 on the bottom, yeah, we'd get root 8 times root 8, which would be 8, and that surd would be gone, but we'd also have to times the root 8 by the 5, so we'd get 5 root 8, and then we'd still be in the same problem where we've got 5 root 8 and we've got a surd on the bottom of the fraction. So the only way to get rid of it here is to multiply by something called the conjugate. So if I put 3 add root 2 over 5 add root 8, the only way to get rid of it is to times by 5 minus root 8. Now that is the same but opposite. And what that does is something special. So if I just put those in brackets, because we're going to need to multiply everything by everything. If I do 5 times 5, I get 25. 5 times minus root 8 is minus 5 root 8. Root 8 times 5 is plus 5 root 8. And root 8 times root 8 is just 8, minus 8, because it's minus root 64, which is just 8. And then, because I've got minus 5 root 8 and plus 5 root 8, they're cancelled out. So just on the denominator, I then have 25 take away 8, which is just 17. Now on the numerator, I've got 3 times 5, which is 15. 3 times minus root 8, which is minus 3 root 8. Root 2 times 5, which is plus 5 root 2. And root 2 times root 8, which is minus, because one of them is positive, one of them is negative, root 16. Now root 16 is 4. So this is just take away 4. 15 take away 4 is 11. But we've then got a problem because these surds are different. I can't add them, can't collect them up. I can't add them together or take them away. So root 8 simplifies. And root 8 has a square number factor, so that can be rewritten as root 4 times root 2. Now the square root of 4 is 2. So this is 2 root 2. So if I've got 3 lots of root 8, it's 3 lots of 2 root 2. So I'm going to rewrite this bit just over here. Minus 3 root 8 add 5 root 2 is minus 3 lots of 2 root 2 add 5 root 2. And that is minus 6 root 2 add 5 root 2, which is just minus 1 root 2. Now we don't bother with the 1, it's just minus root 2. And therefore we've got what they got. The histogram shows information about the ages of the members of a football supporters club. There are 20 members aged between 25 and 30. One member of the club is chosen at random. What is the probability that this member is more than 30 years old? So with a histogram, what we really need to remember is that the area equals the frequency. So how many people are in each category is shown by the area. So the area of this bar and the area of this bar just tells you how many people are in that category. So the only one we've been told that there are 20 members in this bar here, the bar that goes from 25 to 30. Now if that bar has an area of 20, we know that the area of a rectangle is base times height. The base is 5, so the height must be 4. So the frequency density is just what the height needs to be in order to make the area correct for how many people are in it. So if that's 4, that one's 3, that one's 2, and that's 1. Now I can work out the area of all the bars and find out how many people are in each section. So for this first section here, base times height on that rectangle, it's 10 wide on the bottom here, and it's got a height of 0.7. 10 times 0.7 is just 7 people. So there's 7 people in that category there. The next one is 15 wide. 15 times 2, so 30 people there. We know there are 20 people in this one. The next one is 20 times 2.6. 2.6 times 2 is 5.2, and then times that by 10, so that's 52 people in that section there. And last but not least, in this one, we've got 30 multiplied by 0.3, and that is 9 people in that section there. Sorry, it's quite hard to see, isn't it? 7 people in that section, 30 people in that section, 20, 52, and 9. It then says one member of the club is chosen at random. What is the probability that they're more than 30 years old? So more than 30 years old, we're looking at the people on this side of age 30 years, and there is 52 of them in the 30 to 50 category and 9 of them in the next category. So that's 61 people. Adding it all together, I've got 7, add 30, add 20, add 52, add 9. So I've got 16, 17, 18, carry the 1. 3, add 2, add 5 is 10, add the 1 is 11. So the probability is 61 out of 118 people.